As the Chinese proverb says, a journey of 1,000 miles begins with a single step. Today's a big day. You're taking your first step in your journey to learn how to write scripts in Python. It's going to be a little challenging at times, but really it's not that scary. We'll go slow and give you everything you need to fully grasp each concept before we move along. In the next few videos, we'll discover the fundamental concepts of computer programming. You'll learn what a programming language is, what scripting is, what languages are out there other than Python, and how this all relates to IT. We'll also have you coding before you know it, with small coding exercises we've cooked up to give you hands-on practice with Python. This will include writing your very first Python script. But always keep in mind, if at any point along the way you feel lost or confused, don't panic. You can watch the videos as many times as you need to let the concepts sink in. Plus, you can ask questions in the discussion forums, which is one of the best ways to find extra information and connect with other learners. When I was asked to participate in this program, it made me think about when I first started to code. If I could give that younger version of myself a piece of advice, this is what I would tell her. It never works the first time. Seriously, as a newbie, I expected it all to work like magic. I thought that following the rules and getting it right the first time would prove my value as a coder, but that's just not true. Not even the best of the best. If you expect to write perfect code on the first shot, you're going to be disappointed. You hear that, younger self? Try not to feel overwhelmed by the details. Connecting the dots only comes with experience, so best way to learn is to just jump in. The truth is, everyone learns at their own pace. If you already know some of these concepts, feel free to skip ahead to the parts that interest you the most. If you're starting from scratch, take as long as you need for each concept. The assessments will be right there waiting for you when you're done. And if at any point you start doubting yourself, remember, even the most advanced programmers started thinking, Python? What's Python? Well, we're about to learn all about it, so let's dive in. Next up, we'll be doing a rundown of what programming is. At a basic level, a computer program is a recipe of instructions that tells your computer what to do. When you write a program, you create a step-by-step recipe of what needs to be done to complete a task. And when your computer executes the program, it reads what you wrote and follows your instructions to the letter. How nice is that? The recipe is written in a code called programming language. Programming languages are actually similar to human spoken languages since they have a syntax and semantics. Now, if it's been a while since your last grammar class, here's a quick refresher on syntax and semantics. In a human language, syntax is the rules for how a sentence is constructed, while semantics refers to the actual meaning of the statements. In English, sentences generally have both a subject, that's a person, place, or thing, and a predicate, usually a verb, and a statement that explains what the subject is doing. Let's take the sentence, Paula loves to program in Python, as an example. In this sentence, Paula is the subject, and loves to program in Python is the predicate. To form a sentence that others can understand, you need to know both the syntax that constructs the sentence and the semantics that gives it meaning. The same applies to programming languages. In a programming language like Python, the syntax is the rules for how each instruction is written, and the semantics is the effects the instructions have. Much like spoken languages, there are lots of programming languages to choose from. Each has its own history, features, and applications, but they all share the same fundamental ideas. So once you understand the basic concepts in one programming language, it becomes much easier to learn another. And lastly, computers always do exactly what they're told. So when you write a program, it's important to be super clear about what you want the computer to do. Learning the syntax and semantics of the programming language you choose will allow you to do just that. Make sense? Before we continue, let's spend a moment on terminology. In the next few videos, you'll hear the term script being used a bunch. So what's the difference between a script and a program? The line between the two can be a bit blurry, and in this course, we'll use the terms interchangeably. In general, you can think of scripts as programs with a short development cycle that can be created and deployed rapidly. In other words, a script is a program that is short, simple, and can be written very quickly. In this course, we'll focus on a specific scripting language called Python, which we'll use to learn the basics of programming. We'll learn about the Python syntax, the rules of how to write a Python program, and the semantics, or meaning, of the different pieces involved. Before we start learning how to code and having you write your first Python script, let's talk more about what automation is and why it's useful. Although we might not realize it, we reap the benefits of automation all the time in our daily lives. Do you ever pay your bills with scheduled payments or use a self-checkout at the grocery store? I always set my coffee machine to start brewing before I've even gotten out of bed. The promise of fresh coffee makes early mornings way easier. Automation is the process of replacing a manual step with one that happens automatically. Take a traffic light, for example, which continuously regulates the flow of vehicles at an intersection. A traffic light requires a human intervention only when it needs repairs or maintenance. The automatic regulation of traffic means that humans don't have to stand at the intersection, manually signaling when cars should stop or go. Instead, people can concentrate on more complex, creative, or difficult tasks like focusing on where you're driving. What's more, traffic lights don't get tired, bored, or accidentally display a green light when they meant red. This highlights another benefit of automation: consistency. Let's face it, us humans are flawed and sometimes we make mistakes. A human performing the same task hundreds of times will never be as consistent as a machine doing the same thing. But for all of its advantages, automation isn't a solution for every situation. Some tasks just aren't suited for automation. For example, they may require a degree of creativity or flexibility that automatic systems can't provide. Or, for more complicated or less frequently executed tasks, creating the automation may actually be more effort or cost than it's worth. Think about when you get a haircut. What would it take to automate the actions of cutting hair with a machine? The client's height, the shape of their head, their current hair length, and desired hairstyle would all need to be taken into account when designing the automatic system. We'd need to replicate the creativity and skills of a trained specialist, along with extensive testing to ensure the client's safety and quality haircut. And if you've ever had a bad experience at a hair salon, you know quality can be subjective. In this case, the cost and effort of automation just isn't worth the benefits of an automatic haircut would provide, which is why we don't have robot hairstylists. Not too complex, right? Automation is a powerful tool when used in the right place at the right moment. It can save time, reduce errors, increase consistency, and provide a way to centralize solutions and mistakes, making them easier to fix. Throughout this course, and in upcoming ones, we'll be talking about when it makes sense to apply automation and exactly how you do it. Eventually, knowing when and where to use automation will become automatic for you. Working in IT, a lot of what we do boils down to using a computer to perform a certain task. In your job, you might create user accounts, configure the network, install software, back up existing data, or execute a whole range of other computer-based tasks from day to day. Back in my first IT job, I realized that every day I came into work, I typed the same 3 commands to authenticate into systems. Those credentials timed out every day by design for security reasons. So I created a script that would automatically run these commands for me every morning to avoid having to type them myself. Funny enough, the team that monitors anomalous activity discovered my little invention and contacted me to remove it. Oops. Tasks performed by a computer that need to be done multiple times with little variation are really well suited for automation. Because when you automate a task, you avoid the possibility of human errors and reduce the time it takes to do it. Imagine this scenario. Your company had a booth at a recent conference and has gathered a huge list of emails from people interested in learning more about your products. You want to send these people your monthly email newsletter, but some of the people on the list are already subscribed to receive it. So how do you make sure everyone receives your newsletter without accidentally sending it to the same person twice? Well, you could manually check each email address one by one to make sure you only add new ones to the list. Sounds boring and inefficient, right? It could be, and it's also more error-prone. You might accidentally miss new emails or add emails that were already there. Or it might get so boring you fall asleep at your desk. Even your automated coffee machine won't help you out there. So what could you do instead? You could get the computer to do the work for you. You could write a program that checks for duplicates and then adds each new email to the list. Your computer will do exactly as it's told, no matter how many emails there are in the list. So it won't get tired or make any mistakes. Even better, once you've written the program, you can use the same code in the future situations, saving you even more time. Pretty cool, right? It gets better. Think about when you're going to send these emails out. If you send them out manually, you'll have to send the same email to everybody. Personalizing the emails would be way too much manual work. If instead you use automation to send them, you could have the name and company of each person added to the email automatically. The result? More effective emails without you spending hours inserting names into the text. Automating tasks allows you to focus on projects that are a better use of your time, letting computers do the boring stuff for you. Learning how to program is the first step to being able to do this. If you want to get computers to do the work for you, you're in the right place. Earlier in this video, I told you about the first task I ever automated. Now I want to tell you about the coolest thing I ever automated. It was a script that changed a bunch of access permissions for a whole lot of Google internal services. The script traversed a large directory tree with tons of different files, checked the file contents, and then updated the permissions to the services based on the conditions that I laid out in the script. Okay, I admit I'm a total nerd, but I still think it's really cool. In this course, we'll use the Python programming language to demonstrate basic programming concepts and how to apply them to writing scripts. We mentioned that there are a bunch of programming languages out there. So why pick Python? Well, we chose Python for a few reasons. First off, programming in Python usually feels similar to using a human language. This is because Python makes it easy to express what we want to do with syntax that's easy to read and write. Check out this example. There's a lot to unpack here, so don't worry if you don't understand it right away. We'll get into the nitty-gritty details later in the course. But even if you've never seen a line of code before, you might be able to guess what this code does. It defines a list with names of friends and then creates a greeting for each name in the list. Now it's your turn to make friends with Python. Try it out and see what happens. Throughout this course, you'll execute Python code using your web browser. We'll start with some small coding exercises using code blocks, just like the one you experimented with. Later on, as you develop your skills, you'll work on larger, more complex coding exercises using other tools. Getting good at something takes a whole lot of practice, and programming in Python is no different. We recommend that you practice every example we share in this course on your own. If you don't have Python installed on your machine, no worries. You can still practice using an online Python interpreter. Check out the next reading for links to the most popular Python interpreters available online. Now, I'm sure you're wondering, what the heck is a Python interpreter? In programming, an interpreter is the program that reads and executes code. Remember how we said a computer program is like a recipe with step-by-step instructions? Well, if your recipe is written in Python, the Python interpreter is the program that reads what's in the recipe and translates it into instructions for your computer to follow. Eventually, you'll want to install Python on your computer so you can run it locally and experiment with it as much as you like. We'll guide you through how to install Python in the upcoming course, but you don't have to have it installed to get your first taste of Python. You can practice with the quizzes we provide and with the online interpreters and code pads that we'll give you links to in the next reading. We'll provide a whole bunch of exercises for you, but feel free to come up with your own and share them in the discussion forums. Feel free to get creative. This is your chance to show off your new skills. Remember how we mentioned that Python is simple and easy to use? Python makes it easy to express the fundamental concepts of programming, like data structures and algorithms, with easy-to-read syntax. This makes Python a great language to use to learn programming. And there are other reasons to pick Python too. Python is super popular in the IT industry, making it one of the most common programming languages used today. Python isn't new. Its first version was released by Guido van Rossum back in 1991. Since then, the community that develops it has grown and the language has advanced a lot. Whenever there's a significant change to the semantics or syntax of the language, a new major version is released. In 2000, Python 2 was released. In 2008, we got Python 3. In this course, we'll use Python 3.7, which came out in 2018. For many years, Python was considered a beginner's language and was mostly used for teaching concepts or writing very small, simple scripts, like in this course. But in recent years, the adoption of Python has grown dramatically. One reason for this is that the language has become more powerful. It's also because there's more tools available in Python for a growing range of applications. You can use Python to calculate statistics, run your e-commerce site, process images, interact with web services, and do a whole host of other tasks. Python is perfect for automation. It lets you automate everyday tasks by writing simple scripts that are easy to understand and easy to maintain. That's why Python is the language of choice for lots of people working in IT support, system administration, and web development. Not only that, but it's also used in fast-growing areas of IT like machine learning or data analytics. Last but not least, Python is available for download on a wide variety of operating systems like Windows, Linux, and Mac OS. And what's more, Python is so popular in the workplace that if you are currently working in IT, you've most likely encountered it already. And if you're planning for a career in IT, chances are you'll interact with Python quite a bit. So, there's a whole lot of reasons for why Python is relevant to today's IT industry. A large part of programming is learning through trial and error and asking questions. So if at any point you get stuck, don't get discouraged. Making mistakes helps you improve. The more you see failure or broken code as an opportunity to learn, the quicker you'll master programming. I remember the first Python script I ever wrote. It took a lot of refactoring, debugging, and testing to get it to work. I relied on a lot of my teammates for help and mentorship and wound up spending more time on Stack Overflow than actually writing the code. Thankfully, you don't have to reinvent the wheel. There's almost always someone on the internet who's tried to do what you're doing and can help point you in the right direction when you're stuck. Sometimes it takes a village. It's really important to keep in mind that even experienced programmers may need to ask a colleague a question from time to time, or look something up on the internet. Whether you're a programming novice or have some experience in software development, remember, the best programmers overcome challenges by seeking help or using other resources. Once you've completed this program, you'll be well on your way to confidently programming in basic Python. There's lots of information online that will help you continue to develop your programming skills. For example, there are lots of online courses for specific programming languages. You'll find answers to your Python coding questions in the official Python documentation. You can use sites like Stack Overflow to discuss and share with other developers, and you can ask questions in our discussion forums. You can even subscribe to some of the Python mailing lists to keep in the know on the latest updates to the language. You're opening the door to the whole world of programming, and it's super exciting to be joining the development community. The most important thing to remember is that you're never alone. Any questions you may have, any time in your career, there are resources out there to help you find the answers you need. Although we picked Python for this course, it's important to note that it's just one of the many coding languages out there. Think of a given programming language as just one of the many powerful tools in your IT toolbox. Each language has its unique set of pros and cons. Some run faster than others, some are better suited for enterprise applications, others are particularly good at crunching numbers. There are platform-specific scripting languages like PowerShell, which is used on Windows, and Bash, which is used on Linux. Both are widely used by system administrators on those platforms. There are also general-purpose scripting languages similar to Python, like Perl or Ruby, which are also widely used for scripting and automation. JavaScript, which was originally developed as a client-side scripting language for the web, is increasingly used as server-side for a broader set of tasks. And the list doesn't stop there. There's a vast array of traditional languages to explore, like C, C++, Java, or Go. As you progress in your career in IT, you'll probably encounter a number of different languages and learn when to use each of them. But let's not get ahead of ourselves. First, we have Python to get our heads around. A nice feature of learning the basics of programming in one language is that you can generally apply the same concepts you learn to other languages. This means that once you're familiar with Python, you'll find it easier to pick up new coding languages, as you'll spot and understand similarities and differences between them. After all, every language needs to do some common things like create variables, control the flow of a program, read input, and display output, even if they do these tasks using different approaches. As we called out earlier, learning a programming language is somewhat similar to learning a foreign language. You'll need to grasp the syntax and semantics for that language. Luckily for us, once you know the fundamentals of programming, learning another language is much easier than learning a second foreign language. There are a lot more similarities between programming languages than differences. To explore some of the similarities and differences between various scripting languages, let's take a look at a simple program that prints the words "Hello World" 10 times in 3 different languages: Python, Bash, and PowerShell. As you can see, each language uses a different approach to printing "Hello World." But look closer and you'll see similarities too. Each language must somehow put text onto the screen. The command for Python is print, for Bash it's echo, and for PowerShell it's write host. Also notice that each language has to count to 10 in some way. While Python does this by specifying range 10, Bash uses a sequence notation to count from 1 to 10. PowerShell has the most complex syntax in this example, but it also boils down to starting at 1 and counting up to 10. So, as we've just seen, there's a whole lot of programming languages out there. But don't let that scare you. In this course, you will only need to focus on learning Python. Once you can speak Python, you can go on to learn any other language you want. Now that you've got an idea of what Python code looks like, let's check out one of the most basic examples and dive deeper into what's going on. Get ready. We're going to use a Python interpreter to make our computers say hello to the world. When we run this code, either locally on our machine or on a web interpreter, the words "Hello World" appear on the screen, just like magic. Actually, it's not magic. It's because print is a Python function that writes what we tell it to on the screen. Like the statement "Hello World," for example. The print function is part of the basic Python language. Whenever we use keywords or functions that are part of the language, we're using the programming language's syntax to tell the computer what to do. So, what are functions and keywords? Functions are pieces of code that perform a unit of work. We'll talk a lot more about functions later on, and you'll even learn how to write your own. Keywords are reserved words that are used to construct instructions. These words are the core part of the language and can only be used in specific ways. Some examples include if, while, and for. We'll explain all of those and a bunch more later in the course. As we called out, the keywords and functions used in Python are what makes up the syntax of the language. Once we understand how they work, we can use them to construct more complex expressions that get the computer to do what we want it to do. Last off, notice how "Hello World" is written between double quotation marks. Wrapping text in quotation marks indicates that the text is considered a string, which means it's text that will be manipulated by our script. In programming, any text that isn't inside quotation marks is considered part of the code. Now for a bit of trivia. Do you know why we greeted the whole world in our example? Well, printing "Hello World" has been the traditional way to start learning a programming language since way back in the 70s, when it was used as the first example in a famous programming book called the C Programming Language. That example looked like this. In Python, the "Hello World" example is just 1 line. In C, it's 3 lines. In other languages, it could be even more. While learning to write "Hello World" won't teach you the whole language, it gives you a first impression of how functions are used and how a program written in that language looks. Alright, now that we've written our first piece of Python code, I think you're ready for something a bit more challenging than "Hello World." Ready? Let's do it. On the whole, for a program to be useful, it needs to get at least some information from the user. With this data, the program can take actions that are relevant to the user, instead of generic actions like printing "Hello World." Data can be provided to a computer in a bunch of different ways. For example, on a website, you might input data by entering text into text fields or clicking links. If you're using a mobile application, maybe you'll click on buttons or select preferences from a drop-down menu. In a command line program, you might provide additional data by passing strings as parameters to the program, or you could have the program ask you for data interactively. All these various platforms, programs, and apps process data differently. Some might take the contents of a file as data to be processed, others gather data from other sources and process it in the background. Remember our earlier example when we automated the process of identifying and removing duplicate emails? There, the data provided to the program was the list of emails, which would usually be given in a file that lists the emails one per line. Whichever way your application gets the data, it will need to come from somewhere. For our first examples in this course, we'll just have the data as its own line in our block of code. This is limited, but straightforward. Later in this course, and in upcoming courses, we'll introduce you to better ways of feeding data into your code. For now though, let's see this idea in action in a very simple example. By having the name separate from the call to the print function, we're making the line of code that calls the print function generic, while still personalizing the greeting. If we then wanted to say hello to a different person, we only need to change the name, but the call to the print function will remain the same. Pretty simple, right? Next up, we'll learn a few other easy things that you can get Python to do for you. There's a ton of things that you could do with Python, and you'll learn many of them in this course. But before we dive into complex subjects, let's have some fun with another simple task that you could do with Python. We're going to make Python our calculator. And let's start with something easy. So, 4 plus 5 is 9. 9 times 7 is 63. Minus 1 divided by 4 is minus 0.25. Easy. Repeating or periodic numbers are printed in a longer format. Let's try 1 divided by 3. In math theory, when 1 is divided by 3, the digit 3 repeats forever after the decimal point. Of course, it's hard to display something that repeats forever, so instead we have a representation showing lots of decimal places. Not too hard, right? Let's give the computer something a bit trickier. Let's say we want to divide 2050 by 5, then subtract 32, and then divide the result by 9. To do this, we'll need to use parentheses, just as we do in typical math problems. You can also use Python to get squares, cubes, or any power of n of a number. For example, let's say we want to find out what 2 to the power of 10 is. To get Python to give us the answer, we use the double star operator. If you're starting to worry that this is becoming an algebra course, relax, we're not going to do anything more complex than what we've just seen. And if you're thinking, why would I use Python instead of just a normal calculator? That's a valid question. Experimenting in this way, you get familiar with the language's math capabilities. And in IT jobs, there are many tasks that require you to use math calculations. You might need to count how many times a certain word appears in a text, or work out the average time it takes for an operation to complete, or how much you have to compress an image to fit in certain size constraints. Whatever you need to calculate, writing a script can help you do it faster and with more accuracy. So you need to know what mathematical operations are available to you. Python actually has a lot more advanced numeric capabilities that are used for data analysis, statistics, machine learning, and other scientific applications. We won't get into these in this course, but if you want to learn more about them on your own, there's a wealth of online resources available.
Congratulations on finishing this lesson in the Google IT Automation with Python certificate. Access the full experience, including job search help, and get the official certificate by clicking the icon or the link in the description. Watch the next lesson in the course by clicking here, and subscribe to our channel for more lessons from upcoming Google Career Certificates.